So guys, we are starting with logarithmic differentiation. Uh, this is exercise 8K of your textbook. Okay. So now, first of all, when to use logarithmic differentiation? This is logarithmic differentiation. Okay. When to use? So we have to use this when we are having base with x, base in terms of x and power in terms of x, power with x. Okay. So this is the first instance where we use logarithmic differentiation, and multiple terms with multiplication or division and powers and powers. So this is where we use logarithmic differentiation. So base with x or with and power with x, and multiple terms with multiplication and or division with powers with indices. Okay, so I'll take some basic problems so that you people are well aware of uh, how to proceed. So let us go to the first problem, that is question number 8. Exercise 8K, question number 8. So sin x raised to x. Okay, so this is your basic question, and the main question given in the problem is like find the derivative of the following function. Now this is why. This is why because y is a function of x. This entire thing is a function of x. I have denoted it with y. Okay, all these things you should know. Now look at the base. Look at the base. So we are having base with x, and look at the power with x. So when we are having base with x and power with x, okay, we have to use logarithmic differentiation. Fine. So taking log on both the sides, log y is equal to log sin x raised to x. Okay, now we have a property log a raised to b, which is equal to b log a. Okay, so this property you all know. So if you consider this as a and this as b, so b will come ahead, log a raised to b, that is b log. Okay, so this property I'm applying now. So log y is equal to x log sin x. Okay, this term came out due to the property. Now all the log properties are applied. Now when we apply all the log properties, we are going to derive this. Okay, derive this with respect to x on both the sides. Okay, now guys, the derivative of log x with respect to x is 1 upon x. Derivative of log y with respect to x, we are doing d by dx, na? So with respect to x. So this will be 1 upon 1. Right? Okay, so let's go back to the main slide. So derivative of log y is 1 upon y. But you observe the chain rule. You observe the chain rule over here. What is x getting replaced with? Anyone? What is x getting replaced with? You can put it over chat. What is x getting replaced with? X is getting replaced with y. Here also x is getting replaced with y. Okay. So I'll just write d by dx of y into d by dx of y. This is due to chain rule. Now this part, okay. This is u and this entire term is v. So we are going to use product rule over here. So v derivative of u plus u derivative of v. log sin x derivative of x plus x into dy dx of log sin x. Fine. So 1 upon y dy by dx, dy dx of y is dy by dx, okay, is equal to log sin x will remain as it is. Dy dx of x is 1. Dy dx of x is 1 plus x is x derivative of log sin x. Okay, it is 1 upon sin x. This is chain rule. Okay, dy dx of anyone derivative of, what should I write within the bracket? Waiting for your reply. Sin x. Okay, that's the chain rule. So 1 upon y dy by dx is equal to log sin x plus x upon sin x. Dy dx of sin x is cos x. Dy dx of sin x is cos x. Okay. Now we are interested in I will cross multiply this y on the other side. I'll cross multiply this y on the other side. Okay. And at the same time, cos x upon sin x. That's optional. This you can, it is optional. Cos x upon sin x, you can write it as cot x. Preferably write it. Something is very easy, just don't leave it as it is. So dy by dx I'm shifting y on the other side. Put a big box bracket. I've shifted this y on the other side, and this entire term I'll write within the box bracket. Log sin x plus x cot x. Log sin x plus x cot x. Fine. So dy by dx equal. What is the value of y? It's given in the problem. The value of y is given in the problem. The value of y is sin x the whole raised to x. So just replace y with sin x the whole raised to x, box bracket, log sin x plus x cot x. Log sin x plus x cot x. Okay, yes or no? Any feedback? Have you understood this problem? Okay. Now if you look at question number 9, 10, 11, 12, 13, 14. 8 we have done, 9 to 14. Okay, you can take it for self study because each problem is of the similar category. Each problem is of the similar category. 9 to 14. Fine. Still, I will help you with question number 12. Let's solve at least question number 12 from this. Y is equal to x raised to log x. Now, if you take a look at the denominator, this is x. So base is with x term, power is also with x term. Power is also with x term. So when base is with x and power is with x, what do? We take logarithmic differentiation. So log y is equal to log x raised to log x. Now this is a and this is b. So log a raised to b is equal to b log a. So this b will come ahead over here. So log y is equal to log x. B came ahead into log x. Okay. So you can write this log x the whole square, but then instead I will prefer u into v rule. That's more easy. Okay. So once this b part came ahead over here, I got this. Now I'm going to derive this with respect to x. I'm going to derive this with respect to x. Derivative of log y with respect to x is 1 upon y, 1 upon y dy dx of, will you help me over here? What should be the part of the round bracket? What should be the part of the round bracket? Y, correct. Okay. And log x into log x, I'll apply u into v rule. This is u and this is v. Okay. If you're doing log x the whole square, then first x raised to n formula will come. Otherwise, do u v rule. Okay. So log x v derivative of u plus u derivative of v. Okay. 1 upon y dy by dx is equal to log x into 1 upon x plus log x into 1 upon x. Derivative of log x is 1 upon x. So dy by dx, cross multiply y on the other side. So this is log x upon x plus log x upon x. Log x into 1 upon x is log x upon x. Okay. Yeah. So log x upon x plus log x upon x. It is twice log x upon x. 2 times log x upon x. A plus a is 2a. That logic I am applying. And at the same time, the value of y I am going to replace from the main statement. So dy by dx, y is equal to x raised to log x into 2 log x upon x. That's it. That's the final answer. Yes. Any feedback? Are you understanding? So I've given you question number 8 to 14. Some of the problems I have solved. Some problems you are supposed to solve. Okay, so I'll just proceed now. Let's go to question number 15. Okay, let's go to question number 15. So the question is y is equal to 1 upon 1 plus 1 upon x raised to x. So base is with x. Base is with x. This is the base. The base is with x term and power is also with x. Base with x, power with x. So whenever we have base with x and power with x, we are going to apply logarithmic differentiation. Right? So taking log on both the sides, taking log on both the sides. Now this is a and this is b. B comes ahead. So log y is equal to b log 1 plus 1 upon x. So b is x. Okay, b is x. Now we'll apply derivative. Left hand side, you already know. Derivative of log y is 1 upon y dy dx of y. Right hand side, we are going to apply u into v rule. U into v rule. Right hand side. Okay. So left hand side will be derivative of log y. Derivative of log y is 1 upon y dy dx of y. 1 upon y dy dx of y equal to right hand side product rule. Log 1 plus 1 upon x into dy dx of x plus x dy dx of log 1 plus 1 upon x. 1 upon y dy by dx is equal to log 1 plus 1 upon x into 1 plus x d by dx of log 1 plus 1 upon x. Guys, what is the derivative of log 1 plus 1 upon x? Okay, so here also chain rule will be applicable. It will be 1 upon 1 plus 1 upon x d by dx of 1 plus 1 upon x. Guys, just give me feedback about this step. Have you understood this particular step? Because it was not very easy. If you have understood, nothing like it. Okay, great. Now what I'll do is I'll put this y on the right hand side and put a box bracket besides y. Okay, and at the same time, here I'm going to take LCM and here I'm going to derivative. So derivative of 1 is 0 and derivative of 1 upon x is minus 1 upon x square. So the derivative of this entire term is minus 1 upon x square. This entire term. Okay, all these things I'll do. So dy by dx, cross multiply y on the other side, log 1 plus 1 upon x. If you want to take LCM in this bracket, then also you can do just take LCM if you want. Hardly matters. Plus x into 1 upon x plus 1 upon x. What I did is I took LCM over here and x is already there. And now I'll write minus 1 upon x square as the last term over there. Okay, so dy by dx is equal to y log x plus 1 upon x plus, now this term will go up, denominator will become numerator, x square upon x plus 1 minus 1 upon x square. Okay, so x square is getting cancelled. Dy by dx log x plus 1 upon x minus 1 upon x plus 1 plus into minus is minus. Okay, and y, what is y? 1 plus 1 upon x raised to x. Okay, have you understood this? Okay, so let's go to question number 16. 1 6. Question number 16. Y is equal to x raised to x into root x. X raised to x into root x. Okay, We'll play with indices over here. X raised to x into x raised to half. So base is same. Power will get added. Okay. There will be addition of the powers. Since the base is same. Now we have base with x and power with x. The base is with x and the power is with x as well. So we will consider doing logarithmic differentiation. Okay. Now this is a and this is b. So log y is equal to b. B is x plus half log x. Okay. Here I have not applied any derivatives. Here first I am doing making use of the log properties. Okay. Making use of the log properties. Fine. Okay. So derivative of y is log y is 1 upon y d by dx of y. And right hand side I'll be doing u into v rule. That is product rule. So 1 upon y d by dx of y equal to log x d by dx of x plus half log x d by dx of x plus half plus x plus half d by dx of log x. So 1 upon y dy by dx equal to log x. X derivative is 1, half derivative is 0 plus x plus half derivative of log x is 1 upon x. Send y on the other side. Okay. So box bracket log x into 1 that is log x plus the LCM over here 2x plus 1 upon 2 into 1 upon x. Okay. Last step I'm not writing, I'm just explaining. Replace the value of y with whatever is given in the problem and this 2 into x can be written as 2x. That step you people are supposed to write towards the end. Okay, fine. Yeah. So that was question number 15 for you all. Question number 17. Sorry. Yeah, this was question number 16 for you all. Let us go to question number 18, sub question 3. Let us go to 18, sub question 3. Fine. So the problem is x raised to y is equal to y raised to x. Now see, in all the previous problems, whatever we have done till now, it was y equal to something. Okay? But then here, x and y are together. So these are called as implicit functions. When x and y are together, these are called as implicit functions. There is one complete exercise based on this. But then it's okay if you don't have the knowledge of the same because I'm going to explain this right now. Okay. So basically look at the left hand side. Just remember x and y are together, it is implicit functions. Look at the left hand side. Is base with x? Will you reply? Is base with x? Yes. Is power with x? That's the main question. Power is with y, but then what is y? Y is function of x. So just tell me in the left hand side over here, is base with x and power also with x? Will you reply? Hello? Is base with x and power with x? Respond fast, come on. Hello, hello, hello. My question is in the left hand side. The left hand side is what? X raised to y. I'm asking is base with x and power also with x? Base is with x, that is for sure. Power is also with x. This is also x. Why y is x? Because y is a function of x. Are you able to understand? Yes or no? So once again, I'm asking you: is left hand side base with x and power with x? Now tell me about the right hand side. Okay, is base with x and power with x? Okay, so the logic is yes, y is also a function of x. So base is also with x and power is also with x. So anywhere in the problem it is if base with x and power with x, we take logarithmic differentiation. So take log on both the sides. Log x raised to y, log y raised to x. So y log x, log a raised to b on both the sides is equal to x log y. Okay. Now derivate this. Guys, how to derivate y log x? Can you tell me? How to derivate y log x? It's not chain rule. How to derivate y log x? Y into log x. It's product rule. U and v. Product rule. Derivative of the right hand side. Again, it's u into v. Are you understanding? Yes or no? Okay, great. So I'll start now. V derivative of u. So log x derivative of y. Let me check whether I'm writing the correct thing. Correct. Log x derivative of y plus y derivative of log x. Okay. Right hand side. Log y derivative of x plus x derivative of log y. Okay. So log x dy by dx plus y into 1 upon x equal to log y into 1. Derivative of x is 1 plus x. What is derivative of log y? 1 upon y dy dx of 1. Have you understood this much or you need some more explanation? Or you need some more explanation? Please tell me. Okay, so log x dy by dx plus y upon x. This is y upon x is equal to log y plus x upon y. So x upon y dy by dx. Okay, x upon y dy by dx. Now what I will do is I'll combine the dy by dx terms. This term and this term I will group. These two terms I will group. Fine. And the terms which do not have dy by dx, that I will keep on the right hand side. Okay. So this term I'll shift on the left hand side. This term I'll shift on the right hand side. Take dy by dx terms together. So log x dy by dx minus x upon y dy by dx equal to equal to sorry log y minus y by x. Log y minus y upon x. Okay. Now there is something common in the terms of the left hand side. So dy by dx is common. Dy by dx log x minus x upon y log y minus y upon x. Dy by dx y will go over here y log x minus x upon y. X will go over here x log y minus y upon x. Okay. Let me know if you have understood this much. Come on. Yes, please tell me. If I get a response, I'll be confident that you are able to understand. Okay, so after this particular step, what I'm going to do is I'm going to cross multiply y over here and this entire term down, cross multiply. Okay, that is the last step of the problem. So dy by dx is equal to y. Just see, I'm taking this y on the other side. X log y minus y. X log y minus y. Put a bracket but upon x, sorry, upon x into y log x minus x. Y log x minus x. So this is your final answer. Even if you multiply that x and y terms in the round brackets, that's fine. But then it will not make any impact. Okay. Yeah. Let us go to the next problem. Fine. So let us go to question number 18, sub question 3. Okay. So the problem is cos x raised to y is equal to sin y raised to x. My first question to all of you, Left hand side. Look at the left hand side. Is this x term basis with x? Yes or no? Is the power with x? Is power an x term? Answer is yes or no. Yes, because y is a function of x. Okay. Yeah. Good. So now what we are going to do is, since basis with x, power is with x, we are going to take log on both the sides. Okay, because right hand side also has the same thing, base with x and power with x. So this is exactly similar to the previous problem. Okay, log a raised to b formula just apply, y will come ahead and x will come ahead. So y log cos x plus x log sin y. Okay, derivate this product rule on the left hand side, product rule on the right hand side. So log cos x dy dx of y plus y dy dx of log cos x equal to right hand side log sin y dy dx of x log sin y dy dx of x plus x dy dx of log sin y. Look at this term. So it is log cos x into dy by dx plus, look at this term, y into, okay, I need your help over here. What is the derivative of log cos x? Is it 1 upon cos x dy dx of anyone? Derivative of cos x, correct. And derivative of cos is minus sign in the next step. Okay, equal to, look at this term, log sin y dy dx of x, dy dx of x is 1 plus x derivative of log sin y. So 1 upon sin y dy dx of sin y. Fine. So these are your next two steps. Okay. Now the most important thing is over here. Derivative of sin y. What is the derivative of sin y? Precisely, can you tell me? Cos y is correct, but then is that it, or we need to do something more over and above that? Derivative of sin y. We're differentiating with respect to x. So we are comparing this with sin x. If you compare this with sin x, who is x? X is y and hence dy dx of y. Perfect. And at the same time, this dy dx of cos x will be written as minus sin x. Other terms are simplified. So log cos x dy by dx log cos x dy by dx plus y 1 upon cos x into minus sin x equal to log sin y log sin y plus x upon sin y into cos y dy dx of y. X upon sin y into cos y dy dx of y. Okay. So log cos x dy by dx minus this plus into this minus is minus. Sin x upon cos x is tan x. So it is y tan x equal to log sin y cos y upon sin y cot y dy by dx. Okay. Now take this term on the left hand side and take this term on the right hand side, because we are supposed to group the terms which are dy by dx. We are supposed to group the terms which are having dy by dx. So log cos x dy by dx minus x cot y dy by dx is equal to log sin y plus y tan x. Log sin y plus y tan x. Okay. Now look at the left hand side. Look at the left hand side. Anything in common in the left hand side? Yes, dy by dx term is common. So take dy by dx common term. Let's put a bracket. Log cos x minus x cot y. Log cos x minus x cot y equal to log sin y plus y tan x. Log sin y plus y tan x. Now cross multiply. This term just cross multiply will get the answer. Dy by dx is equal to log sin y plus y tan x upon log cos x minus x cot y. That's it. Fine. Have you understood this problem, guys? Or you need some explanation? Just give me a feedback. Okay. So let us go to question number 7. There are 3 sub questions. Okay. So I'll just solve one problem for you. 7 sub question 1, 2, and 3. You can take it for self study. 7 sub question 1. So the term is x raised to 1 upon x. So let this be y, because y is a function of x. Okay. Now base is with x and power is also with x. If that is the case, we'll take log on both the sides. Log y log x raised to 1 upon x. Okay. So log y, take this 1 upon x and into log x. So log y is equal to log x upon x. 1 upon x into log x is log x upon x. After this, you derive it. Left hand side chain rule, 1 upon y d by dx of y. The right hand side quotient rule. Right hand side will be quotient rule. Okay, u upon v. So derivative of log y. Derivative of log y is 1 upon y d by dx of y. Right hand side just apply quotient rule. Log x upon x. Log x upon x quotient rule. U upon v. V derivative of u minus v derivative of u minus u derivative of e upon v square. So dy by dx. Shift this y on the other side. The box bracket over here. Okay. X into 1 upon x. This log x derivative is 1 upon x. Okay. Minus log x into dy dx of x, which is 1. Okay. Right. So this x and this x will get cancelled. Put the value of y from the problem. Y is, just let me check what is y. Y is x raised to 1 upon x. Okay. And this is 1 minus log x upon x squared. That's your final answer. X raised to 1 upon x, that is the value of y. And the simplified form of the box bracket is 1 minus log x upon x squared. Okay. So 7 sub question 2 and 3 you can do it on your own. If you're facing any difficulties, you can certainly ask me. We'll just proceed. Yeah. So let's go ahead with question number 19. Right. Question number 19. So question number 19 is, yes, I'll go to the previous slide. Don't worry. Yes. If you have any queries, you can please ask. Okay. Let me know once you're done. Okay. So let's go to question number 19. Yes. And just a second. Yeah. Y is equal to e raised to x minus y. Okay. Now you might wonder like whether the right hand side is base with x and power with x. No, that is not the case. Base is not x, but in power absolutely it is with respect to x. X minus y both are x terms, but in base is not x. Okay, right? So what you can do is you can solve directly, or you can also take log on both the sides, because if we take log on both the sides, we'll get some benefits. If you want to directly derivate this, if you want to directly dy dx over here, that also works. That is also not a problem. So it is any which ways you can solve this particular problem. I'll directly derivate this. Okay. So derivative of left hand side y is dy by dx. Okay. Derivative of e raised to x minus 1. Derivative of e raised to x is e raised to x. E raised to x minus y is e raised to x minus 1. Okay. Into dy dx of. Can you help me with this information? Into dy dx of. Into dy dx of x minus 1. Perfect. Okay. Change it. Now look at the proof, what we are supposed to prove. Look at the problem statement in the textbook. Do we require this in our proof? Do we require this term in our proof? The answer is no. We don't require this. So what is the value of e raised to x minus y? Can you tell me? The value of e raised to x minus y. E raised to x minus y is y. How it is y? How is e raised to x minus y y? Why have written this e raised to x minus y as y? Because it's given in the question. E raised to x minus y is y. Have you got a point? Have you got a point? Okay. Yes or no, guys? I'm just waiting for your reply. Yeah. Thank you. So now the derivative of x is 1 over here, and derivative of y is dy by dx. Derivative of y is dy by dx. Okay. I'm going to do one bracket on the right hand side. Just open this bracket. Y into 1 minus dy by dx. So dy by dx, y into y dy by dx. What I did is, like, if I go to the previous slide, I multiplied y with both the terms. Okay. So I'll just give you a recap of whatever I have been doing in this problem. Okay. So first thing is, I explained that no need of logarithmic differentiation, but then you can certainly apply logarithmic differentiation, not a problem. Because power is there, right? I applied chain rule. E raised to x minus y derivative is e raised to x minus y. X is getting replaced with x minus y, so derivative of x minus y. Okay. Then e raised to x minus y. The value of e raised to x minus y is y. Replace it with that, because this time we are not finding out dy by dx. We are proving dy by dx is equal to something. Okay. So that's the logic. And then d by dx of x is 1. This is dy by dx. Right? Then I'm multiplying y with both the terms in the bracket. Now take dy by dx terms together. Send this term on the left hand side, so it will be plus y dy by dx equal to y. Take dy by dx common, 1 plus y is equal to y, and then cross multiply. Therefore, dy by dx, this 1 plus y will come down over here, y upon 1 plus y, y upon 1 plus y. Okay. Hence proved. So this is our required problem statement. So we have proved this. Okay. Now we'll be solving question number 26. Okay, that's fine. Let's go to question number 26. X raised to y is equal to e raised to x minus y. E raised to y minus x, sorry. Here it is base with x and power with x. The left hand side is base with x and power with x. So whenever we are having base with x and power with x, okay, what we are going to do? We are going to use logarithmic differentiation. So log, here we have to take log because left hand side is base with x and power with x. Y will come ahead, y minus x will come ahead. So y log x, y minus x log e. Okay. When y minus x it is coming ahead, I'm just putting a bracket for it. Guys, do you know the value of log e? The value of log e is 1. We are taking the base as e. Okay, so forget about the base and everything because I don't want to go in all such details. So just remember log e is equal to 1 in our entire calculus. Okay, chalo. In these three steps, do you have any doubts in these three steps? Okay, fine, perfect. So y minus x into 1 is y minus x. So y log x into y equal to y minus x, right? Now take a look at the proof. You can derive at this particular point also, not a problem. But then just take a look at the proof. If you're taking a look at the proof, right hand side, are you observing something? 2 minus log x upon 1 minus log x the whole square. What is your observation about the right hand side? Can you tell me? So in the right hand side, there is no y term. There is nothing in terms of y. Okay, that should be your observation. So instead of differentiating this directly, you can do that. It's not wrong. But then I would avoid this right now because I'm observing in the proof. It's a proof problem, right? So we need to apply some more logic. Okay, there is no y. Fine. So what I will do is, sorry, I will combine all the x terms and combine all the y terms. So this term and this term I'll combine. For that reason, I'm going to send this x on the left hand side and I'm going to send this on the right hand side. So x is equal to y plus y log x. So x is equal to y 1 plus log x. X is equal to y 1 plus log x. And finally, what is the value of y? Y is equal to x upon 1 plus log x. Y is equal to x upon 1 plus log x. Now it is better for me to derive. Now I will derive. Okay. So the derivative of y is dy by dx. Derivative of the right hand side. Derivative of the right hand side is quotient rule. So I'll just write v the bracket dy dx of u minus u dy dx of u upon v square upon v square. Okay. D by dx of x is 1. D by dx of 1 plus log x. Derivative of 1 is 0 and derivative of log x is 1 upon x. I'm going to replace these values wherever I have encircled with the orange marker. So what I will do is I'll write the next step. Dy by dx is equal to 1 plus log x into 1. 1 plus log x into 1 minus x into 1 upon x. So this is x. 1 plus log x is 1 upon x. Fine. Upon 1 plus log x the whole square. So dy by dx 1 plus log x into 1 is 1 plus log x minus this x and this x is getting cancelled. Okay. 1 plus log x the whole square. So this is equal to log x upon 1 plus log x the whole square. Let me check. I just find some discrepancy in this particular solution. Just a moment. Somewhere something I have copied wrong. Let me just go back and verify. This is y minus x into 1 and y log x. Oh, I just copied the sign wrong. When I send this y log x on the right hand side, this should be minus. I'm very sorry for that. Okay, so please pardon. And this is minus. Okay, so x upon 1 minus log x. X upon, I just have to make these changes everywhere. Extremely sorry. Okay, so the derivative of 1 minus log x is minus 1 upon x. This is minus 1 upon x. Okay, and this is minus 1 upon x. This minus and this minus is plus, so this will be plus. So this will be log x plus 2. Now let me check whether the answer is 1 second. 1 minus log x. No? 1 minus log x into 1 minus x. Still I'm making some changes. So this is minus over here. Okay. So 1 minus log x plus 1. So 2 minus log x. Now have we got our proof? Can someone check? Is this what is required? This minus into this minus is plus. Yes guys, is this what is required? Yes, so yes. So I just checked the final statement of the proof. It is very much the same. Fine. Okay. So this was guys lecture number 1 based on logarithmic differentiation.